Well, welcome to Regents Review, January 2017, multiple choice. The first question says, which expression is equivalent to 16x squared take away 36? So there's two things you're supposed to really notice here, that you have a subtraction, and in that subtraction, both of these two numbers can be divided by 4, and what gave me the hint to look for the 4 was the fact that two of the choices had a 4 on the front. So I'm going to factor that 4, divide it out of both pieces, put it on the front, divide 4 out of 16, and you still end up with 4, and the x squared comes along for the ride. And then divide 4 out of 36, and you get 9. Now, this is the difference of two perfect squares. 4x squared is a perfect square, because 2x times 2x makes 4x squared. And 9 is a perfect square, because 3 times 3 makes 9. The 4 is still on the front. And when you have a difference of perfect squares, because you're trying to multiply to make a negative 9, you've got to have a positive and a negative. So between choice 1 and 2, the only one that got the symbols right is choice 2. And there was a question from my class, how am I going to notice, or what's basically reinforce this pattern for me? So if you saw something like x squared minus 25, x squared is a perfect square of x and x. 25 is a perfect square of 5 and 5, plus and a minus, and that one would be factored all the way out. The only difference with this question is they made you divide something out to begin with. Okay, the next one says, what is the solution of the equation x subtract 2 times x subtract a equals 0? And what you're supposed to remember is that when things are in parentheses, the solutions are going to be the opposite numbers. So negative 2 is going to turn into a positive 2, and negative a is going to turn into positive a. So if I made up another question like that and said x minus 5 and x plus b, your two answers would be a positive 5 and a negative b, because you're taking the opposites of what they give you in parentheses. Number 3, it says, analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of negative 0.524. Which statement best summarizes this result? So it's a negative correlation because it's a negative number. So get rid of the answers that say positive correlation. And now we have to decide, is it strong or moderate? Now, strong would be really close to positive 1 or negative 1, so very close to 1. This is 0.52, so you're only halfway there. So this one would be a moderate negative correlation. Strong would be like 0.9, maybe 0.88, something like that. Okay, next one. This one is looking harder than it really is. It's what we call a literal equation. It means when you're solving for one letter in terms of the other. So you're trying to get one of the letters by itself, one of the variables by itself. So it says solve for P2. So they want the P2 by itself. You have P1, V1 equals P2, V2. Well, if I'm solving for P2, then the only other thing that's stuck on his side is the V2. I've got to divide by it in order to cancel it. Whatever I do to one side, I've got to do to the other side. So P1, V1 over V2 is equal to P2. This is P2 in terms of, or written with an expression with the other letters. So that's choice 3. Next one. Okay, a radio station did a survey, blah, 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 blah. What percentage of college students prefer classic rock? So this is what we call a marginal calculation or marginal probability, because we're not using the whole chart. What percent of the college students, which is just this row, prefer classic rock? So it's 14 divided by the total in this row. And if you add those three things up, you get 50. So it's 14 out of 50, not 14 out of the whole chart. And 14 out of 50, if you type that in the calculator, gets you 0.28. And 0.28 is 28%. So whenever they say what percentage of a certain group, you circle that group or pretend that's your whole group. Okay, next one. It's talking about zeros. And we say zeros and roots and solutions all sort of correspond to the x-intercepts. And they're telling you -4 and +2. So we want a graph that touches the x-axis at -4 and +2. Two of them, they graphed for you, and 2 of them, they just gave you the equation and you've got to graph it. I feel like looking at the pictures they gave you first, and you're going to notice it touches at -4 and +2 right here on number 4, so I don't even need to look at the rest of them. There's only one right answer, so there it is. Number 7. Number 7 says which expression is equivalent to, and then they have you give a bunch of simplified functions. So while that's starting up, I'm going to go ahead and do the workout and distribute the 2. So that gives you 6g take away 8, and distribute the negative. So negative 8g subtract 3. A positive 6g and a negative 8g are going to make negative 2g. But you notice all of the choices have negative 2g. Then the thing we've got to get right is the negative 8 subtract 3. That's take away 11 if you type that on the calculator. That shouldn't be too hard to do. Somebody who gets 5, you got this answer, it's because you forgot to make the 3 be a negative. You didn't distribute and make that positive turn into a negative. Number 8. In 2014, the cost to mail a letter was 49 cents for up to 1 ounce. Each additional ounce costs 21 cents. Which recursive function could be used to determine the cost of a 3-ounce letter in cents? So it starts at 49 and it's going up by 21. So my starting number is 49. It's going up by 21. That's choice 1. The rest of these aren't giving you a correct recursive function because they don't start you at the right number. They all start at 0 or 21, and it clearly says start at 49 cents for 1 ounce. 1 ounce is the first term, not 0. A car leaves Albany, New York, and travels westward toward Buffalo. The equation D equals 280 take away 59t can be used to represent the distance D from Buffalo after t hours. In this equation, the 59 represents what? So if it's the total distance from where you're trying to get, and you're subtracting from that, you're subtracting how much you go every hour from that. So that 59 is really the speed of the car. 280 is how far you've got to go, and you're taking away 59 miles every hour. So taking away 59 miles means the 59 is the speed of the car. Number 10. Faith wants to use the formula C of F equals da 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 da, and we've got to figure out C of 68. So I'm going to go ahead and use the graphing calculator. I just need to get it up here for y'all. So I'm going to use the graphing calculator to figure out this answer. Go to y equals and type in that actual formula. Alpha y equals is how you get fractions. So I've got 5/9 multiplied by, and I can't use f, but I can use x in the calculator. X minus 32. Then they ask us to plug in or substitute in 68. So I can go second table and scroll all the way down to 68. Might take a minute. But that'll tell me the temperature when I convert 68 into Celsius. Looks like 20 degrees is the answer. So it's either going to be choice 1 or choice 2. So we subbed in 68. And what we were plugging in was an F value. So if we plugged in F, that means what we got out was Celsius. So it's 20 degrees Celsius. Next thing says, which scenario represents exponential growth? And exponential growth should be multiplying, not adding. Linear is adding or subtracting. So water tank is filled at 2 gallons per minute. That means you're adding 2 gallons every minute. That's adding and subtracting, so that's linear. A vine grows 6 inches every week. Adding, linear. A species of fly doubles. That means times 2. So that sounds like my exponential. And then the last one, the car increases its distance from a garage and travels 25 miles per hour. You're only adding a certain amount of distance every hour. So it is choice 3 because it says doubles. So exponential growth often applies to bugs, bacteria, any like rodents, that kind of thing. Also money with interest grows exponentially, so you're looking for multiplying. Number 12 says, what is the minimum value of that function? So I'm going to go to y equals and type in that function. Trouble is, a lot of people don't know how to get those absolute value bars. Second zero, good. So I have x plus 3 inside the bars, and then outside the bars, subtract 2. If I graph it, you should be able to see that the minimum value is -2. But if I want to go and jump back in my table to starting at 0, you can see that the lowest value you get, yep, -2. It goes from 0 down to -1, down to -2, and then goes back up again. So the lowest value you have is -2. The -3 is when it occurs. That's a trap answer because that's your x value. When they ask for minimum, they really are talking about y. Number 13 says, what type of relationship exists between the number of pages printed on a printer and the amount of ink used by the printer? So first off, if one goes up, the other goes up. You print more pages, you're using more ink. When one goes up and the other goes up, that's a positive correlation. Negative correlation is like when the more you text in class, the lower your grades are, right? Potentially, if you're texting too much. So that would be a negative correlation. When one thing increases, the other thing decreases. This is a positive relationship. Then we have to decide, is it causal? Is it cause and effect, or is it just coincidence that they kind of go up together, or they tend to happen together? And I think you could agree that when you print more, you're absolutely going to have to use more ink. So it's causal. Very often they give you ones that aren't causal, but that one was one that was causal. Number 14 says a computer application generates a sequence, and they give you a function where n is the number of the note in the sequence, and so on. They said which function will generate the same note sequence. In other words, which function is the same? So what we should definitely do is do this in the calculator, and don't worry about all of your exponent rules or anything. If I'm asking which one is the same, then I'm asking which one's going to give me the same graph or the same table. So if I type the original one in, 6 multiplied by 16 to the n, I can't say n, so I'm going to say x. Then we pick one that we want to guess. So I have a class in front of me. Which one do you guys want to guess? All right, so if we guess 2, I'll try it out, and I'll type it in. So 6 multiplied by 2 to the 4x. And if this is the right answer, then their tables should match. And look at that, we got lucky. Good guess. And they match completely. So that is the right answer. If I type another one in, let's say I type in choice 3, because that tends to be most people's guess. So 12 times 4 to the 2x. And if I go ahead and look at the table, you see they're similar but not the same numbers. So those two would not be equal. So we already know our guess was right, so we can move on. But all you have to do is compare each one until you find the one that matches. Good question. So a question from the class was, what do these E's mean? The E is a scientific notation because they couldn't fit the number in there. So when we have E6, it's really 6 million because you're moving your decimal 6 times to get those, 6 spaces after the millions. And if it's E7, then that would be like in the tens of millions and so on. So when you see the E, it's scientific notation. If it's E with a negative number, it's a very small decimal. So it's really shorthand for scientific notation. Okay, for this one, it says which value of x is a solution to this equation. Now, a solution is something that works, right? So I think rather than solving this equation, since it is multiple choice, the surest way to get this right is to substitute each one in and see which one actually comes out to being -12. So we could type in 13, take away 36 times, and then try an x value. So let's say I do the first one, 36 over 25 squared, and then you press enter and see what it equals. If it equals 12, then that would be the right answer. So go back to your home screen and you just try each one and see which one gives you -12. 13, subtract 36, give yourself a fraction. If it's 36 over 25, finish the parentheses and squared. It doesn't give me 12, so I know choice 1 isn't the right answer. Do you guys want to pick another guess? Okay, let's try 3. So negative 6/5 is what I'm going to sub in, and I don't want to retype everything. I'm just going to go over here and delete the parts that I don't need. Negative. Doesn't come out to 12, so it's not right, or negative 12. You want 4 or 2? All right, so if I go to 2, that should be 25 over 36. Oops. Doesn't turn out, so it better be choice 4. But since we've come this far, you might as well check and be sure you did it right. Otherwise, your methodology might be flawed. So we're going to say it's a negative 5 over a regular 6. And it does come out to negative 12, so it was choice 4. Yeah, the other one was 6 over negative 5. This one's negative 5, 6. So they flipped the answers. Okay. This one says which point is a solution to the system below. In other words, which point actually works in both equations. Okay, this is a system of inequalities, which means shading graphs. So usually we're going to shade two graphs. One will shade up, the other shade down, or something like that, and we look for where they're both shaded. One of these is already ready to type in, and the other one isn't. I need to do a little bit of work on this one. So 2y is less than negative 12x plus 4. I always want to solve equations for y. Y. How come y? And the button on the calculator says y equals. So we're going to divide by 2 everywhere. So y is less than, oh, I shouldn't have said equal to. It was just less than negative 6x plus 2. So I've got two equations to type in, or two inequalities to type in my graph, and look at them both. You might notice they both have the same slope, and they have two different y-intercepts. So I'm going to type them both in, and I've got negative 6x plus 4, and I've got negative 6x plus 2. And if these will graph quickly because I'm on the computer emulator and not on the calculator, so I'm going to do the second one with a little ball so you can see it go slowly. So here's the first one, and then the second one's right below it, really, really close. You also will hopefully notice that both of the symbols are less than symbols, so it means I'm shading below. So I have one graph where I'm shading below, and then the other graph that's really close to it, and then shading below him. So your solution zone is anything really that's below the second graph. If it's below the second graph, it will definitely be below the first graph because they're parallel. So I really only have to find a point that works for the second equation, the one that has the plus 2. So if you look at the points on the actual graphing calculator, negative 3, positive 2 looks like it'll definitely be below both of those. So that is the right choice. If you check each of the other ones out, it's either going to end up on the line or between or above the other line, so it's not going to shade the right way. Next one, 17, says if x squared, f of x equals x squared, is multiplied by the value a, where a is greater than 1, the graph of the new function g of x does what? So we'll go to the calculator and look and try some numbers. So I have x squared, and then would you like to give me a number? Bigger than 1. Okay, so if I say 5x squared, the first one will graph as the original, the second one is the 5. And you can see that it still opens upward, but it's narrower, right? It's skinnier. It's squished in, so it still opens upward, but it's narrower. The way it would open downward is if I made a be a negative number, and it flipped downward. Compressed, that's a good word for it. So Andy has $310 in his account. Each week he withdraws $30 for his expenses. Which expression could be used if you wanted to find out how much money he had after 8 weeks? So if you're going to make an equation for this, his initial value is 310. And then he's taking away $30 every week. The trouble is that choice isn't there. The closest thing looking to it is 3 or 1. But you see how they put the W on the wrong piece in number 3, and you know that's not right because it's taking away 30 every week. 310 should be a plain number because that's where we're starting. This one's taking away 8 every week, and you do see 8 in the problem, but that's 8 weeks. In other words, 8 is the W. So this one's a trap answer they're trying to get you to pick because you see the 8 and the 310 in the problem. They're trying to get you to just be complacent or pick the one that you see to be the easiest. One of these two guys is actually equal to our correct answer. There's nothing wrong with what we built, but we have to go ahead and sort of distribute and combine like terms and see which one of their answers is actually worth ours. So they tried not to make it too easy for you. Plus, we're all the way up to question 18, which you know now we're starting to get into the hard ones, so they're a little bit tricky. Not hard, but tricky. So 280, if I distribute that, you're going to have plus 30W take away 30. And if I combine like terms on these two, 280 take away 30 is 250 plus 30W. That's saying he has $250 to start and he's adding $30 every week. That can't be right. So we're pretty sure it's choice 4, but let's just verify it for the heck of it. So if I go ahead and say 280 and distribute the negative 30, take away $30 every week, and then plus 30 because we had to distribute the negative 30 to the negative 1. That makes a positive 30 because negative times a negative makes a positive. Now if I combine like terms, I've got 310 minus 30W, and it's exactly what we said to begin with. So choice 4 is the right answer. It just didn't look like ours, but it was equal to ours. Okay, 19. Looking at the choices, there's no solving here. They're just asking what type of numbers make the most sense. So this is the daily cost of production in a factory. It's calculated by using C. So cost is money. And they said where X is the number of complete products manufactured. So this could be like cell phones or computers or Hatchimals. I don't know, some kind of toy or something, like video game system. But it's not a half-made system. So if we're talking about complete products, which numbers best defines the domain of C of X? And is domain X or is domain Y? So I've got two words, domain and range. X goes with domain, Y goes with range, input goes with domain, output goes with range. Notice that the beginning of the alphabet in each case is the X value. So domain, range, D comes before R. X, Y, X comes before Y. I, O, I comes before O. So in every single case, you can get, they go in alphabetical order so you can know which one goes with which. They're asking about domain, so they're asking about our X values. Well, I told you X is the number of complete products. So if there have to be complete products, they have to be whole. They have to be whole numbers because you can't have negative products. Integers are nice numbers without decimals on them, but they could be negative. We're not talking about negative cell phones or negative things that they're making. So it's got to be whole numbers is the domain. Next one, 20. This is some statistics talking about mean, median, spread of the data, which is your standard deviation. So Noah conducted a survey. He made some dot plots. It's basically just the ages of soccer players and ages of basketball players. And you might be able to notice something about the data. The basketball players have more of older kids, and the soccer players have more of a balance. So if we're talking about the average, who's going to have a higher average? Basketball players, right? Because there's more older kids. So they're talking about mean right here. Basketball players have a greater mean. That's higher average. So that makes sense because there's more old kids in their group. 21. We've done this question in class, I know. So it's talking about the average resting heart rate, and you have it for like newborns all the way up to 50 years old, really, really old people, 50. So a 10-year-old has the same average resting heart rate as a 20-year-old. 10-year-old, 20-year-old, are they the same? No. So this is no. A 20-year-old has the same resting heart rate as a 30-year-old. Yes. A 40-year-old has the same resting heart rate for 10 years. Yes. The average resting heart rate for teenagers, so from 10 to 20, steadily decreases. Yes. So this one they must have been asking for the no, and if you go back and look, which one is not supported by the graph, that's the number one reason people got this question wrong, is they would pick choice 2 because they picked the first yes that they found, but the question was for the not. So the answer is choice 1. Okay, this next one is tricky. It says the method of completing the square was used to solve the equation 2x squared minus 12x plus 6 equals 0. Now, to truly complete the square, it's an algebraic technique. So we would have to go ahead and write it down so we have room to work. And whenever possible, if there's a leading coefficient, a number on x squared, you want to divide it out of everything. And this one does divide out nicely, so we're going to do that. And now I've got x squared minus 6x plus 3 equals 0. This is what I'm really going to complete the square on. So keep that in mind, that this is equivalent really to the original equation. We just divide it out of 2. In order to complete the square, what you usually do is you're going to move your constant term to the other side. Oops, that's going to be subtract 3. Subtract 3 from both sides. And in the place of that 3 that you used to have, we're going to leave a blank. Because we're going to add something to both sides. We're going to kind of play math god so that we can create a perfect square. This is going to factor for us into x and x, just like we did in the beginning of the regents. But the number that goes here has got to be half as big as the middle term. So basically all you do is divide by 2. That's going to be negative 3 and negative 3. The number that goes back up in this other blank that we made is going to be whatever the product of these two is. So negative 3 times negative 3 is positive 9. And whatever I add to the left side, I have to add to the right. So now this side is going to equal 6. Sorry about that. The late bell music came on. So the last thing we have going on here is to simplify it. This is something times itself. Well, when you have something times itself, you can say it's just that thing squared. The 6 is still there, so it's choice 1. That's not a very easy technique to master. So one other thing that you could have considered doing was thinking about if you recognized that this had a 2 on the x squared and none of these things have a 2 on the front, that we could divide out and end up here. Then really all I have to do is consider which one of these choices is equivalent to the x squared take away 6x plus 3 equals 0. None of your choices equal 0, so you'd have to move the number back over. But if I wanted to say, for example, take choice 1, x subtract 3 squared, take away 6, because in order to move this over into that side, I would have to take away 6. Then I could compare using the test function on the calculator to see if they're equal. So if I go back into the calculator and type in, let's say, the x squared, take away 6x plus 3, and I want to test, so I'm going to do second math, enter. I want to test to see if this is equal to my choice 1, but I had to move the 6 over next to the parentheses, so it's going to be a negative 6. So x subtract 3 squared, take away 6. And you get a 1. Say, ooh, that's good. That means that those two things are equal. Had I done something like maybe choice 3, which would have been a subtract 3 if I move the positive 3 over to the left side, you see that you get a 0. So the only one that's going to be equivalent is the one that gives you a 1. Whenever you get a 0 on the calculator, that's computer language for false. Okay, 23. Nancy works for a company that offers two types of savings plans. One of them is drawn, Plan A, and the other one they give you an equation for, Plan B. I'll make this a little bigger so we can see it. And it says Nancy wants the plan to have the highest possible savings after a year. Nancy picks Plan B. Her decision is, and we have to decide if she's correct or incorrect. First, you have to know how many weeks a year is. That's 52. And this is counting by twos. So 52 is right here. And if I go up to the graph, it looks like we're landing a little bit above 100,000, maybe 105. So 100 or $105. I guess that's just dollars, not thousands of dollars, but $105. Now, if she picks Plan B, we have to see if, when we substitute in 52, if f of 52 is bigger or smaller than the 105 that we see on the graph. So I can either type that in the y equals, which I think that's what I'm going to do to try to keep my technique consistent for my students, 0.01 plus 0.05 x, oh, and I don't need the parentheses, x squared. And I would go to the table, but I've got to scroll to the 52nd week. You can see that that one's starting off with 1 penny, just like the other one was, but we scrolled to 52 weeks, going. Oh, and you have $135.21. So Nancy picks Plan B. Her decision is correct because she's going to have more money. Now, if we look, there's two that say correct. These say incorrect, so we won't look at them. Now, they don't say because Plan B is higher. They both say that Plan B will be higher, but they say for different reasons. One of them says Plan B is exponential. The other one says Plan B is quadratic. Now, exponential functions are in the form a times b to the x. Where quadratic functions have an x squared in them. This one is clearly a quadratic, so the answer is choice 2. If we had had an x in the exponent, the answer would have been choice 1. Now the last actually gives us an exponential equation. It has a Boston Marathon person, and it says they run as many as 120 miles per week. During the last few weeks of training, his mileage can be modeled by, and they give you the function, where W represents the number of weeks since training began. Which statement is true about the model? Now, some things we should be looking for. He's starting at 120 miles per week. He's decreasing or decaying by 10% per week because that number is less than 1, and it's 10% less than 1, 90% of what we had for each week. The number of miles he runs each week will be increased by 90%. That's not true because he's decreasing by 10%. The number of miles he runs will be 10% of the previous week. No, 10% of means a 90% decrease. That's not right. He's only decreasing by 10%. M of W represents the total mileage given in a week. That sounds right. And then W represents the number of weeks left until the marathon. They said W represents the number of weeks since training began. That's a test of did you read or not. So it is choice 3. Notice that this was the last question in the multiple choice. So for some reason, a lot of students got this wrong. And I'm guessing there's a little bit of fatigue going on there. And people don't read very carefully because this was not very difficult. Just the words were confusing. So remember when you have exponential decay, let's say we still start with 120, just like this equation. Whatever number you have in parentheses, if it's larger than 1, then it's growth. If it's less than 1, it's decay. So if I had 1.25 to the W minus 1, that means I'm increasing by 25% every week. If I change that to be 0.75, it means I'm decreasing by 25% because I'm 25% less than 1. So however much you are bigger than 1 or less than 1 is what you're increasing or decreasing by. This is my growth or decay factor, but my growth or decay rate is how much different you are than 1. All right, good luck with this, and I'll see you hopefully in the extended response video, and we'll continue to post more videos on mrswyan.weebly.com.